Within the wider project, Smart City and Security, the City of Turin initiated a pilot program for managing complex events. This project included a field test during the Pope's last visit to Turin. The focus of the test was to try and evaluate new generation technologies set inside existing ones as well as brand new infrastructures. What did we test? Biometric face scanning within open places in order to process data from a video stream and obtain facial recognition. Video analysis related to crowd positioning. In-cloud transmission of video data using new generation wireless technologies also working in motion. Setup of an efficient and technologically advanced control room suited for emergencies. Data transmission performances are important in these kinds of events, but even more important is having a stable and secure network. That's the reason why fluid mesh network devices were chosen to create the network infrastructure. Fluid mesh networks is a worldwide leader in high bandwidth data transmission, with performances that can be compared to optical fiber. The fluid mesh system creates a dedicated radio channel on unlicensed bands at 5 GHz. Radios can be installed in point-to-point, point-to-multipoint, and mesh topologies as a guarantee of high flexibility and easiness to fit in different environments, allowing high data throughputs as required by the cameras in use here. 3 typologies of access network cameras were positioned in different perspectives. The scope was to verify if, thanks to the latest technology, cameras deployed in a city scenario could provide enough useful images for facial recognition. Those 3 cameras were able to provide high-level image quality for facial recognition. The combination of the 3 perspectives allowed face detection and recognition even in a complex context with disordered, non-channeled people flow with the absence of a traditional checkpoint. Morpho-Argus is a biometric application created by Morpho SA of the Safran Group, distributed in Italy by SIAM, which allows the capture of faces of people standing in a monitored area to compare images within a watch list and to recognize individuals on the spot. In these cases, optimal conditions were created to achieve maximum results in terms of position and light. The usage in open space required a specific setting for the test conducted during the Pope's visit. The selected solution gave excellent results in terms of facial extraction and individual recognition, considering the severe conditions for the applications. CT was involved in the design of a model for the dynamic analysis of crowds and has performed a series of simulations based on different risk scenarios in the context of the papal visit to Turin. The model simulated the evolution of people's positions within a discrete or set time frame, assuming their aim was to reach the exit as fast as possible. The simulations reproduced the location involved, Piazza Vittorio, and the dynamic evolution of the crowd, for example, the position of people through sequential time frames. To conclude, an outdoor installation subject to change right up until the last minute, thousands of people to fill an area in a few hours, and above all, the need for an increase in security without transforming a peaceful gathering into a threatening environment. The performance of a state-of-the-art facial recognition system installed outdoors in a few hours over a wireless network and fed with properly configured cameras can only impress. Of course, this cannot ensure 100% success. Even the most accurate human-based attempt to find a target among 100,000 people is certain to fail, but we have proven that a facial recognition system can do a lot to improve on the security of an event. The verification of the applied crowd behavior model provided useful improvement inputs for future events.